Every moment of our lives, we are part of an extraordinary cosmic dance. The Earth spins on its axis, completing one full rotation approximately every 24 hours, while simultaneously hurtling through space in an orbit around the Sun. These motions are happening at incredible speeds, far beyond what we can easily comprehend. Yet, we don't feel a thing. Why? Understanding this requires us to dive into the origins of Earth's movement and the fundamental laws of physics that govern it. Let's unravel the mysteries of why the Earth spins and why this motion feels imperceptible to us. To understand why the Earth spins, we need to journey back to the birth of the solar system, about 4.5 billion years ago. Back then, a massive, rotating cloud of gas and dust, called the solar nebula, was the cradle of everything in our planetary system. As gravity pulled parts of this nebula together, clumps of material began to form, growing larger over time. During this process, the conservation of angular momentum played a crucial role. This principle in physics states that when a rotating object contracts, it spins faster, just like a figure skater pulling their arms in to accelerate their spin. As the material that would become Earth clumped together, it inherited the rotation of the original nebula. This is why our planet started spinning, and it hasn't stopped since. The Earth's rotation persists because of a fundamental rule of motion first described by Sir Isaac Newton. According to Newton's first law of motion, an object in motion will remain in motion unless acted upon by an external force. In the vacuum of space, there is no significant resistance to slow down the Earth's spin. Unlike objects on Earth, which eventually stop moving due to friction, the planet's rotation continues largely uninterrupted. This perpetual spinning is a direct result of the absence of forces like air resistance or friction that could act as brakes in the vast emptiness of space. The speed at which the Earth rotates is nothing short of mind-blowing. At the equator, the planet spins at roughly 1,670 kilometers per hour, over 1,000 miles per hour. Meanwhile, as the Earth rotates, it also races around the Sun at an orbital speed of approximately 107,000 kilometers per hour, about 67,000 miles per hour. These numbers can be hard to wrap your head around, but they underscore the dynamic and energetic nature of our planet. Despite these incredible velocities, we experience no sense of motion. This apparent paradox is due to the consistency of these movements and the fact that everything on Earth, including its atmosphere, is moving in unison. As we delve deeper, the reasons behind this will become even clearer. The reason we don't feel Earth's motion lies in the nature of how constant and smooth that motion is. Imagine sitting in an airplane flying at a steady speed and altitude. Once the plane reaches cruising speed, you barely feel its movement. You can walk around, eat, or even sleep without any sensation of the plane rushing through the air. The same principle applies to Earth. Because the planet's rotation and orbit around the Sun are steady and uniform, we experience no jolts, stops, or changes that would signal to our senses that we are moving. Our bodies are finely tuned to detect acceleration or changes in velocity, not uniform motion. Since Earth's movements are consistent, they are essentially invisible to us. The force that keeps us firmly planted on the ground is gravity. Earth's massive size creates a gravitational pull strong enough to attract everything on or near its surface toward its center. This gravitational force acts uniformly, pulling us down no matter where we are on the planet. But what about the incredible speed at which Earth rotates? Wouldn't that motion throw us off into space? Not at all. The force of gravity is far stronger than the outward pull caused by the planet's rotation, known as centrifugal force. Even at the equator, where the rotation speed is fastest, gravity easily overpowers this effect. Additionally, Earth's atmosphere rotates along with the planet, meaning there's no wind resistance to disrupt us or fling us off into space. We are safely anchored by gravity, no matter how fast the planet spins. Earth's rotation doesn't just go unnoticed. It actively shapes the world we live in. One of its most significant effects is the Coriolis effect, which influences the movement of air and water on the planet. This phenomenon causes winds to curve rather than move in straight lines, giving rise to weather patterns and ocean currents that make our planet habitable. Without rotation, these systems would behave entirely differently, and life as we know it might not be possible. Furthermore, the rotation impacts Earth's shape. The planet isn't a perfect sphere. It's slightly flattened at the poles and bulging at the equator due to centrifugal force. This subtle flattening has practical effects, such as influencing the gravity we experience at different latitudes. Rotation is more than just a cosmic spin. It's a defining characteristic of how Earth functions and supports life. While the Earth's rotation feels constant to us, it is, in fact, gradually slowing down. This is primarily due to the gravitational interaction between Earth and the Moon, a phenomenon known as tidal braking. The Moon's gravitational pull creates tides on Earth, and as these tidal bulges move slightly ahead of the Moon's orbit due to Earth's rotation, they act like a brake, transferring rotational energy from the Earth to the Moon. As a result, the Moon is slowly moving farther away from Earth, about 3.8 centimeters per year, and Earth's rotation is slowing down. Over millions of years, this has had a noticeable effect. For example, during the time of the dinosaurs, a day on Earth was just 23 hours long. While this change is happening at an incredibly slow pace, lengthening the day by about 1.7 milliseconds per century, it serves as a reminder of the dynamic and ever-changing nature of our planet. Earth's rotation has a profound impact on its physical characteristics. Due to the centrifugal force generated by spinning, the planet is not a perfect sphere but an oblate spheroid, meaning it's slightly flattened at the poles and bulging at the equator. This bulge affects everything from the planet's gravity to the paths of satellites in orbit. Another fascinating consequence of rotation is the phenomenon of true polar wander, where the planet's solid outer shell slowly shifts relative to its axis of rotation. Beyond these physical effects, the idea of Earth's rotation has even influenced human culture. Ancient civilizations tracked the movement of the sun and stars to develop calendars, while modern technology, like GPS systems, relies on precise measurements of Earth's spin. These facts show how deeply intertwined rotation is with both the natural world and human society. The continuous rotation of Earth is a testament to the principles of physics and the vast forces at work in the cosmos. It has shaped our planet's climate, geography, and even the way we measure time. More importantly, it creates the stability needed for life to thrive. While it's easy to take this movement for granted, understanding its origins and effects allows us to appreciate the complexity and beauty of our world. As we stand on this spinning sphere, surrounded by the vastness of space, we are reminded of how much we owe to forces that operate on scales far beyond our everyday experience. The Earth's rotation is more than a simple spin. It's a key part of what makes our home unique in the universe. Now that you know why the Earth spins and why we don't feel it or fall off, why not share your thoughts? What else would you like to learn about our planet or the universe? Drop your ideas in the comments below, and don't forget to like this video and subscribe to the channel. Your support helps us continue exploring amazing scientific curiosities like this one.